The image, first and foremost, is breathtaking. It's filled with countless galaxies, a feature consistent in every image we've received over the years. For decades, black holes have remained among the most mysterious and elusive entities in the universe, hidden behind mathematical theories, digital simulations, and imaginative artistic renderings. As our technology advanced, so too did our fascination. Yet, the notion of directly witnessing the inside of a black hole was long thought to be fundamentally impossible. The boundary encircling these immense objects, known as the event horizon, was believed to be an impenetrable barrier, a point beyond which no light or matter could return. However, this assumption has now been upended. Thanks to the James Webb Space Telescope's unprecedented sensitivity and infrared imaging power, we've received the first actual image of what lies within a black hole. What we see is both awe-inspiring and unlike anything captured before. The discovery emerged from Webb's deep observation of a supermassive black hole located in the core of the galaxy, NGC 7392, situated more than 137 million light-years from Earth. This black hole, estimated to be millions of times heavier than our Sun, had been analyzed in the past. However, those studies relied on indirect methods, like observing the motion of stars and gas orbiting around it. Earlier efforts, such as the Event Horizon Telescope's image of the M87 black hole, showed only the silhouette, the shadow created by the event horizon. But Webb, using high-frequency gravitational mapping paired with infrared spectrum analysis, succeeded in looking past that horizon. What it found matches what, until now, had only existed in scientific theories. The image itself defies ordinary description. At first glance, it doesn't resemble a tangible location, but rather an intense distortion of the fabric of space. Forms seem elongated and fragmented, manipulated by the overwhelming gravity at work. Light itself is pulled and twisted into strange configurations, stretching across a space that appears to have multiple dimensions. The colors shift wildly, blending reds, blues, and deep purples in an erratic yet mesmerizing dance. Despite this visual chaos, an unexpected harmony emerges. There is an eerie symmetry hidden in the disarray. Scientists believe these structures could be the final remnants of stars or dust caught in their last moments before being ripped apart. Perhaps the most stunning detail in the image is a luminous focal point located where the singularity, the black hole's infinitely dense core, is theorized to exist. For the first time, the singularity is no longer just a concept. In Webb's image, it appears as a radiant node of white-blue brilliance, brighter than anything around it. While the light might be caused by matter undergoing extreme compression and deformation, it sparks revolutionary questions about the nature of singularities, energy, and even time itself. This revelation is rewriting what we thought we knew about black holes, and even physics as a whole. Einstein's general relativity, which has elegantly described gravity for 100 years, begins to falter at the singularity. Quantum mechanics, the science of the tiniest particles, has never fit comfortably with relativity. Now, theorists must face this dissonance with direct observational evidence, not just models and equations. Beyond the singularity, space-time itself looks jagged and unstable, folding inward and outward all at once. Webb sensors captured effects that suggest that inside a black hole, dimensions may behave in ways that go beyond human understanding. Some physicists see these features as signs of higher dimensional behavior, ideas once confined to string theory and speculative realms of quantum gravity. If validated, this would be the first real evidence that additional dimensions beyond our known 3 dimensions of space and one of time might actually be real. Equally bewildering are the streaks of energy appearing to shoot outward from the core, only to whip back inward, trapped in a cosmic whirlpool. This could be the most vivid example of frame dragging ever seen, where the rotation of a black hole pulls space-time along with it. The gravitational distortion is so intense in areas of the image that photons, light particles, seem to spiral and loop endlessly around the singularity. These observations could be the first step towards studying gravitational lensing from inside a black hole, not just from its edges. Another mind-blowing observation is the presence of what might be time-dilated matter. These ghost-like shapes near the outer edge of the image appear to be frozen and stretched, as though suspended in time. Near a black hole, time slows dramatically, especially as one approaches the singularity. To an outside viewer, anything falling in would seem to stop, smeared across the threshold forever. Webb may have recorded these visual signatures, offering a first glimpse of time behaving as a visible and measurable force. If this interpretation proves accurate, it would mark a historic moment, when we didn't just measure time, but saw its effects in real space. This leads to profound implications for the black hole information paradox. For decades, scientists have debated whether information that falls into a black hole is destroyed or preserved. Webb's image might offer clues. Patterns within the energy structures hint that information may not vanish, but instead is reformed, encoded into the curves of space-time itself. If this turns out to be true, then the universe may possess an inherent mechanism to preserve information, even in its darkest regions. Perhaps even more startling is the subtle sense of order within what appears to be destruction. Rather than a chaotic abyss, the black hole's interior seems to follow its own internal logic. Strange, yes, but not entirely random. There's rhythm in the streams of energy, repetition in how light and darkness interact. This suggests a level of structure that raises incredible questions. Could black holes serve more than one purpose? Might they act as cosmic engines, transforming matter, energy, and information into something new? Ideas once dismissed as science fiction, like black holes being passageways to other universes or dimensions, now gain traction thanks to this new data. Webb's image doesn't prove these ideas, but it breathes life into them by showing that these realms are no longer beyond our reach. This single image has redefined the frontier of scientific exploration. Around the world, researchers are analyzing every detail, updating their theories, and revisiting previously held assumptions. Webb's image isn't just a photograph, it's a scientific tool. Each light filament and warped shadow carries valuable data, each pixel revealing the secrets of reality. This moment is a philosophical achievement as much as it is scientific. Since ancient times, people have looked to the skies wondering what lies beyond. Black holes have represented the ultimate unknown, a place where everything ends. But now, for the first time, we've cracked open that cosmic mystery and glimpsed what lies inside. What we discovered wasn't a void of lifeless blackness as many had long imagined. It was something far more profound. Instead of simple darkness, the James Webb Space Telescope revealed a strange, intricate beauty hidden within the heart of a black hole. This beauty wasn't just visual. It was conceptual, embedded in the structure and movement of light, energy, and matter in ways that defy traditional understanding. Threads of light, spirals of energy, and distorted fragments of space revealed a dynamic, almost artistic choreography shaped by forces we are only beginning to comprehend. The true power of Webb's observation lies not merely in the unprecedented image it produced, but in the questions it raises. It compels us to rethink everything we thought we knew about space, about time, and about the fundamental nature of gravity. The fabric of reality, once thought to be static and predictable, now appears fluid and sculpted by deeper, hidden forces. Even the very idea of existence, what it means to be real in such an environment, comes under scrutiny. The Webb telescope didn't just show us something new. It shattered boundaries, ushering us into a new era of cosmic understanding where beauty and mystery coexist in the most unlikely of places. The universe is no longer just a canvas of stars and galaxies following predictable laws. It is a constantly evolving landscape, where even darkness glows with hidden structure. This image shows that black holes aren't merely destructive. They may be cosmic laboratories, where the fundamental rules of reality are being rewritten. As technology continues to evolve, future space telescopes equipped with quantum sensors or gravitational detectors may build on what Webb has revealed. This is only the beginning. For now, though, Webb's first image from inside a black hole stands as a defining chapter in the story of human curiosity. We've stared into the ultimate mystery, and it stared back. This glimpse alters how we understand not only the cosmos but our own place within it. Space and time are no longer passive stages. They're dynamic forces. And black holes, once seen as the end, may in fact be a new beginning. If you enjoyed this video, don't forget to hit the like button and subscribe for future updates. Let us know in the comments. What are your thoughts on the black hole image captured by Webb? We'd love to hear your perspective. Thanks for watching, and see you next time.